the last lesson, we looked at how to use a for loop to repeat a set of instructions when we know how many repetitions we want. As we saw, a for loop uses a counter or control variable which by default increases by 1 each time the loop executes, and the loop finishes after the final value of the control variable is reached. So, for example, in a loop that begins for I equals 1 to 5, the control variable I takes on the values 1, 2, 3, 4 and 5 in turn, and when I takes on the next value, which is 6, the loop finishes, as it is to be executed only for values of I from 1 to 5. This means that the set of instructions inside the loop will be executed exactly 5 times, once for each value that I takes on in the loop. In this lesson, we look at some more examples of for loops. And in these examples, we'll make use of the fact that the control variable runs between a starting and finishing value. In the first example, we'll use for loops to display sets of numbers between two specified values. We'll begin by displaying the integers 1 to 10 using a for loop. We'll need to declare a control variable I and use it in a for loop where I will run from 1 to 10. And as I changes value, we'll display it in the list box. Let's look at the code to do this. Here's the code to display the integers 1 to 10. And we see that in our for loop, I takes on the values 1 to 10. And on each pass through the loop, we display the current value of I. As we've said, the value of the control variable I in our loop normally increases by 1 after each pass through the loop. If we want to change I by a value other than 1, we can specify what we call a step value in the first line of the loop. For example, if we want to increase I by 2 on each pass through the loop, we would write for I equals 1 to 10, step 2. Again, the first value of I will be 1, but the next value will be 3, and the next 5, and so on, as I is increased by 2 on each pass through the loop. This means that I will take on the values 1, 3, 5, 7 and 9, which are the odd numbers between 1 and 10. Let's run the program and see the output. So we click the button and we get the odd numbers between 1 and 10 as expected. This is because I starts with a value of 1 and increases by 2 at each step, but stops once it passes 10. Now suppose we want to use our loop to display the even numbers between 1 and 10. In the loop, the first value of I is 1, but the first even number is 2, which is simply I plus 1. Similarly, the next value of I is 3, and again I plus 1 will give us the next even number, which is 4. So if we display I plus 1 on each pass through the loop, we should get the even numbers 2, 4, 6, 8 and 10. So let's run our program again and see what happens this time. And notice before we run it that we're displaying I plus 1 each time we pass through the loop. So again, we click the button and we get the even numbers 2, 4, 6, 8 and 10. Remember, I is still taking the values 1, 3, 5, 7 and 9 in the loop. But we are displaying the number I plus 1 each time, which gives us 2, 4, 6, 8 and 10. We can also use a loop to display values in reverse order by making the step value negative. Let's add the code to display the integers 1 to 10 in reverse order, beginning with 10. This time, the first line of our loop reads, for I equals 10 to 1, step minus 1. This means that the starting value of I is 10, and I decreases by 1 each time the loop executes. And again, on each pass through the loop, we display I. Let's run the code and check the output. And we click the button and we see the integers from 1 to 10 in reverse order, beginning with 10. It's important to note that although we have used integers in all our examples so far, the lower and upper values of the control variable don't need to be integers. And similarly for the step value. For example, if we want to display the values from 1.5 to 5 in steps of 0.5, we could write the following code. This time we've used a control variable x, and x runs from 1.5 to 5 in steps of 0.5. But remember, if we are using non-integer values for our control variable, then it needs to be a single or a double variable. And in this case, we've declared x as double. Let's run the program and see the output. And when we click the button, we can see that x runs from 1.5 to 5 and increases by 0.5 on each pass through the loop.